Hello and welcome. Today, we're venturing into the high-energy universe, where X-ray astronomy is pulling back the curtain on some of its most mind-bending inhabitants, black holes and the colossal jets they can unleash. Leading the charge is NASA's Imaging X-ray Polarimetry Explorer Satellite, or IXPE, giving us fresh eyes on these cosmic powerhouses. For years, a big question in astrophysics was how the jets from supermassive black holes, especially those in blazars that point their jets right at Earth, actually produce X-rays. Were tiny protons the culprits, or was it electrons? Thanks to new findings, it looks like electrons have it. Coordinated observations of the blazar BL laser T, using IXPE and ground-based telescopes, have provided strong evidence. It seems that high-speed electrons within the jet collide with lower-energy photons, like infrared light, and boost their energy up to X-ray levels. This process is known as Compton scattering. The breakthrough came from IXPE's unique ability to measure the polarization of X-ray light, essentially, the orientation of the light waves. Different X-ray production methods result in different polarization signatures. In late November 2023, observations of BL laser T were particularly telling. While its optical light showed an incredibly high polarization, at 47.5%, the X-rays were far less polarized, maxing out at only 7.6%. This disparity strongly favors the Compton scattering model by electrons, as proton-driven X-rays would typically show higher X-ray polarization. IXPE, a joint mission between NASA and the Italian Space Agency launched in December 2021, is truly opening a new window on these extreme environments. Beyond jets, IXPE is also shedding light on the immediate vicinity of black holes, the swirling accretion disk of infalling material and the coronae, a region of superheated plasma. For stellar mass black holes, which are up to about 20 times the mass of our Sun, IXPE can actually help measure the black hole's spin by analyzing X-ray polarization from the disk. So far, these measurements match up well with spin estimates from other methods. When it comes to supermassive black holes, IXPE is giving us our first real look at the shape of their coronae. Previously, ideas were purely theoretical. But IXPE data suggests that for the black holes observed where the corona could be directly measured, it tends to be extended in the same direction as the accretion disk. This helps rule out models like a lamppost corona hovering directly above the disk. Interestingly, this suggests a similar accretion geometry whether the black hole is small or supermassive. Studies of black hole X-ray binaries, where a black hole pulls matter from a companion star, have also yielded some surprises. Several sources have shown higher X-ray polarization than expected, posing new challenges for our theories. For sources with radiojets, the X-ray polarization tends to align with the radiojet direction, suggesting an equatorial geometry for the X-ray emitting corona. These advances don't happen in a vacuum. Combining X-ray data from missions like IXPE with observations from radio, optical, and other telescopes gives us a much more complete picture. Other X-ray missions are also making huge contributions. For example, NASA's NICER instrument is studying quasi-periodic eruptions, repeating X-ray flares from near supermassive black holes. And the X-ray Imaging and Spectroscopy mission, XRISM, a JAXA-NASA collaboration with ESA, is providing unprecedented detail on the material whipping around supermassive black holes by mapping the motion of elements like iron. Looking forward, continued observations with IXPE and other advanced X-ray observatories, alongside increasingly sophisticated simulations, promise to further unravel the complex processes governing how black holes feed and how they launch and shape those powerful jets. Understanding these phenomena is crucial not just for grasping black holes themselves, but also for comprehending their wider impact on their host galaxies and the evolution of the entire universe. Thanks for tuning in.